To help tackle the coronavirus crisis, Bardis and TangentWorks are teaming up to offer their assistance to the healthcare sector by providing a machine learning-driven demand forecasting solution, entirely free of charge. Hospitals are currently struggling to obtain sufficient equipment, such as ventilators, respirators, gloves, patient beds, and testing kits. Hospital staff are also stretched thin. Accurate forecasts of demand for both equipment and staff resources would help hospitals to better plan ahead for the coming weeks and months. Building a forecast model traditionally requires advanced expertise in statistics and programming and can be very time-consuming. TangentWorks have built a new machine learning tool called TIM that can build highly accurate forecast models automatically in only a few seconds. The tool is industry agnostic, and the following demo will show how to build a forecast of the number of users of a bike-sharing service. However, the same approach could be used for predicting the amount of beds or the amount of ventilators required in a specific region or hospital, given the infection rate in that area, for example. So now let's look at the TIM Studio platform and the dataset, which, as I said, is from a bike-sharing program in Washington, D.C. CNT is the count of active users during a given hour. We can zoom in and zoom out, and we can layer in these other variables, such as public holidays, and some weather data, such as wind speed, humidity, and a couple of temperature variables. Our aim here is to forecast the number of users in the future using the other variables as inputs to the model. The fastest way to build a model in TIM is to use the instant forecasting feature. Let's say we want to forecast 7 days into the future. With only a few button clicks and in just a few seconds, we will have our forecast, which has been created using the historical count of users as input, as well as all of the public holiday and weather data. This can be compared to more simplistic univariate forecasting models, which would use only the historical data for the count of users as input. Notice the complexity of data that TIM has modeled. We see these peaks at around 8 a.m. and 5 or 6 p.m. So these are commuters using the bike service on weekdays, whereas at weekends we see these broader peaks centered around early afternoon. We can also see more details of how the model is built. The tree map here shows the input variables that have contributed the most to the predictions. The variables have been transformed by TIM, so we have here a moving average of the target variable, as well as a lag. We also have a sign transform to handle periodicity within a day, and the holiday variable, and so on. TIM figured out automatically which are the most relevant feature transforms to use for this dataset. This is the real value that TIM brings and is why it's so fast. Furthermore, this tree map helps us understand what are the driving factors behind these predictions. TIM can be used via the TIM Studio web platform or via API or via a range of other tools, including Qlik, Power BI, Alteryx, and Excel. To learn more about how to get started with the solution, go to bardis.com/coronavirus.